Hello, I'm Anna Mackay and this video is on plotting or sketching quadratic functions. So our basic quadratic might look approximately like this, and having a look at each section that we've got an arrow pointing to and thinking what they are named. So we're going to go around in an anti-clockwise direction. What would you call the line, the shape of this? We'd call that a parabola. The next one here, what would you name that particular point on a quadratic or any graph, I suppose? An X-intercept. Next, what is the specific name of this point here? It's the Y-intercept. Now, here there's 2 points. There's 2 significant names that we can give this, where the parabola turns. So we give it the name of the vertex. It's also the minimum point of this graph. If it's going the opposite direction, it would be a maximum. You may have heard vertex or turning point before. Second to last over here would be another X-intercept. And the final one is this arrow here. It's pointing to the dotted line here. And that's that, well, it's the point of symmetry. It's an axis of symmetry that the graph turns around, if you like. And also thinking about that, that's a vertical line. And what's the equation of vertical lines? What format are they in? They're in the form of x equals. Now, can I recommend that you have an explore of these 2 investigations? They're in your textbook. We've talked before about students getting to the point from knowledge to understanding and how to make that connection. This is one of those examples where you can explore the 2 types of quadratics here by playing around with the effects of the different variables, if you like, and seeing if you can come up with the rule for the vertex and turning points, that sort of thing. You will deepen your understanding if you discover it yourself, as opposed to me telling you what the rules are. So I'll assume you do that, but I'll move on to summarising what you've discovered. So quadratics of the form where a is not equal to 0, because if you think about that, then we wouldn't have a quadratic, where we have P and Q belong to the real numbers there. It's just a fancy definition. Basically, P and Q are going to be numbers that you're used to dealing with. They can be decimals or fractions, but they're not imaginary. The graph will have that form there. Thinking about which way that's going to, it's smiling, if you like, and that's dependent on that A factor out the front there. And points of interest, P will be one of our X-intercepts, and so will Q over here. And what else can we say about this graph? That the axis of symmetry is actually the average between the 2 X-intercepts. How to find an average? Add them up and divide by how many's there. So the number would be exactly halfway between those, and so it would be the X equals a number would be the axis of symmetry. In this form here, having a look at the quadratic there, what could you say about its factors? Well, it's a repeated factor, and therefore whenever we have a repeated factor, it's a touch. As opposed to cutting the x-axis, the graph will touch it. And where will it touch it at? At the point H. So that point has the coordinates h, 0, because it because the y in the value of the y on the x-axis will be 0. It's really quite significant in that form. It's also the vertex, so it has that form, and the axis of symmetry will be x equal to h, as written neatly there. This form is the form that we get by completing the square. The advantage of this, you may have been wondering, why have I ever needed to complete the square? Because it can put a quadratic into turning point form, or vertex form if you like. So the vertex has the coordinates h, k. And having a look up there at the quadratic in that format, the h is in the bracket here and the k is the constant on the end, and that instantly gives you the vertex, which also gives you the axis of symmetry. So that is handy for when you're doing applied type questions that have maximum and minimums. If you want to find out the coordinate of that turning point instantly, this is the format that's most useful for that. And x equals h is the axis of symmetry. Just summarising some of these here. For quadratics of this form, that the A factor produces the shape. So if A is greater than 0, what will we get? That shape there, what's that called? Concave up is often how it's described. If A is less than 0, the shape will be a negative, an upside down shape. Two versions of what that could be called, concave down or concave convex, you may have seen in some different textbooks. So concave down because it's turning down, or concave up, turning upwards, or concave and convex you may come across from time to time. Now, what effect does A have on the graph? We've got a few things, two versions that it can do. I'm just going to bring these up on the screen here. If we always compare it to the standard quadratic of y equals x squared. So that's going through the origin and concave up. If you have a factor of A in this sense, if it's a large number, or it could be a large negative number, what will the effect will that have on the parabola? Will it narrow it or widen it out to be a large scoop, if you like? One will widen and one will narrow, and the opposite one if A is a fraction or a number less than 1, and the order that it's in is if it's a large number, it's actually going to narrow it. You might have thought it would be the opposite, but it's not. And a smaller fraction number will widen out the parabola. Okay, doing some examples here. We've got 3 here and 1 more. It's asking us to use axis intercepts only to sketch the graphs of this, so not a table of values or anything like that. So how do you set this out? The x-intercept, well, we can see from the factors here. So using your null factor law, hopefully you know that the x-intercepts would be -3 and +1, so changing signs there. Y-intercept, my maths teacher always told me to work out if you're doing the y-intercept, you put the other letter, so x, and put that equal to 0. Same concept applies if you're doing the x-intercept, you make y equal to 0. So you take your function, and where you see an x, you substitute in a 0, and you would have to work that out. And so y is -6. So graphing that, just change my colour here, we've got our axes. Now, first time around, I'm going to try and do it as accurately as possible. We would put arrows on, we'd put x and y, we would label the function when we've done it. Our x-intercepts are -3, perhaps should have left a little bit more room over there, and +1. And y-intercept is -6. Clearly have drawn this out of proportion. So -6 there, 1 there, and a -3. And we have to turn. Now don't be tempted to turn at -6 just because that's a point. Have a think. What's the distance between -3 and 1? 1, 2, 3, 4. So the turning point is halfway between those, which would be at -1. So you just have to roughly sketch. I'm going to put a dot there where I'm going to turn. Sometimes I like to put the turn in first and then extend it up. Always use a pencil when you're doing graphs. The axes can be in pen because if you make mistakes, it's easier to sort out later. And then it's good to label the name of that graph as you see it. All right, let's move on to the other ones. Right, x-intercepts, when it's in this factorized form, it's easy to see what they're going to be. 1 and 2, and the y-intercept, therefore x is equal to 0. We have y is equal to -2. Substituting 0 into that bracket there leaves us with -1, oops, and -2. Multiply all of them together, we get -4. Just while I'm here, I'm actually just going to finish off the other one. X-intercept is using null factor law, we would get -2 there, and our y-intercept, where x is equal to 0, y is equal to 1/2, multiplied by 2, don't forget the square, to give us a grand total of 2. Graphing both of these, often handy to think about which coordinates that you've got first, so that you can try and approximately draw up your axes to match. I'm not going to label my axes and graphs properly, but I trust that you will. So plotting our points, our 2 x-intercepts for this one are 1 and 2, so they're actually quite close together, and a y-intercept of -4, so somewhere down here. Now, one thing I forgot to mention with the first one is thinking about which direction it's going. Is it concave up or concave down. And the way we do that is this A number here. If that's a negative, you might think, well, negative implies sad, and that's a sad face, so it's turning down. If it was a positive number, like in the first one of 2, 2 is positive, that's a happy number, so it's concave up, so a smiley type of face. So that way we have to turn in this second graph here like that and go through our Y-intercept there. And our third and final one, X-intercept of -2. You might also notice because of the squared factor, it will be touching. Now you just have to decide which direction is it going. And our A value is a half, so it's a positive number, and put on our Y-intercept of 2 so we can draw our graph through there. Oh, that's terrible. You need to make sure that that touches on the x-axis there. 2 is much better than mine. Okay, and one more here. Using the vertex, axis of symmetry, and Y-intercept to graph this. So let's go through that one at a time. Vertex, so V for vertex, or spell the whole word out, is of the form with the H and the K. So our H, you change the sign, so we have -1, and the K is 4. So that's going to be our vertex. Axis of symmetry, where does that come from? That's a vertical line. Vertical lines have equation x equals, so we take the x number from the vertex to give us the axis of symmetry. So tick, we've done that one and that one. The y-intercept, therefore the opposite letter equals 0, and we substitute that in to our function up here. So y is equal to -2, 1 squared plus 4, that all comes out to be 2. Sometimes it's handy to write that as a coordinate too, to know what you have to plot. So, axes, using a ruler of course, nothing as dodgy as this. Plotting our points. Our vertex is -1, 4. That's so bad. I'm actually going to rub that out. That's terrible. Let's go again. All right. As straight as one can be on an iPad. Oh, not much better. Anyway, moving on. Our y-intercept of 2, a vertex of -1, 4, 4 there, -1 here, and so we're using the vertex, check, axis of symmetry, so we should put that in, dashed line of x is equal to -1, and the y-intercept of 2, making sure it goes through 2, trying to have it as a curve at the top, arrows on the end, label the function y equals, and label your axes x and y, etc. And you're done. Okay, make sure you subscribe to the channel, and the next one is 2D.1 sketching by completing the square. Thank you.